Hey everybody, it's time for some science. Alright, let me pose a scenario to you. You're going 92 in a 55, like one of my students recently was, and you see a cop up ahead. Now you've got two options. You can either try to slow down before you get to him, in which case maybe you'll be under the speed limit in time and you won't get a ticket, or you can try to speed up and outrun him. So regardless of which decision you make and how smart that decision may be, both of them require you to change your velocity. You have to either slow down or speed up. And what we call a change in velocity is acceleration. So what we're going to do today is we're going to observe some changes in velocity or lack of changes, and we're going to see what that does to the slope of our line when we graph velocity over time. Doing that will tell us some things about acceleration and how we can find it, and how we can use acceleration to predict the movement of an object. So let's go ahead and get started. Okay, so what you should have along with this video is a guided set of notes. And what we're going to do is we're going to fill them out together, and this is going to become sort of the ultimate cheat sheet for defining movement based on a graph. This sheet, by observing these very simple motions and keeping track of what it does to the velocity and acceleration, this will allow us to predict more complicated movements later on. So let's start with probably the simplest movement you can do, just staying perfectly still, and we'll see what that happens on this graph of velocity over time right here. All right. Okay. So as you can see, the car did not move, nothing happened on the graph. What does that look like when you sketch it out? Let's take a look. Okay, so this graph is going to be pretty straightforward. As time goes on, velocity just stays at 0 because we're not moving at all. Our speed is 0 meters per second. So when I sketch that out, zoop, there we go. Should just be pretty much a straight line. You can see mine dips a little bit. That has more to do with my handwriting than it does with the actual graph. Okay, so let's get that onto our notes, and then we'll fill out the rest of it. Okay, so I got my graph right here. Now let's describe which way the cart was moving. It wasn't. It wasn't. All right, pretty straightforward. So then what is happening to the velocity? Well, the velocity is staying at 0. Staying at 0, which means the velocity is 0. And now let's think about our acceleration, which is going to be the slope of the line, how steep it is in either direction. Because we just have this nice flat line, our acceleration is also 0. Okay, so let's look at another very basic example. We're going to have a cart move at a constant velocity to the right. Let's see what that looks like. Oh. Okay, so I'm going to pause it right there. You can see that the actual sensor stopped picking things up around right here. We don't really care about that. What we care about is this little section right here where the sensor was picking it up and the cart was moving constantly. So let's kind of look at what that graph would look like if we zoomed in on just that moment. So if we were to zoom in on that, you'd see that the velocity jumps up and then just stays there for that brief moment when the sensor was picking up the movement. So what that's going to look like when we zoom in, roughly, is a positive but straight line. So now we're in the positive. This is, we'll estimate about 1 meter a second. 1 meter per second. But just the same flat line, but up. So let's put that on our notes now. Okay, so I have the graph on my notes. Mine's a little cleaned up, and then we need to fill in the rest of this. So which way is it moving? Well, it's moving to the right. To the right. And we could be specific and say at a constant velocity, but I think for now, that's as specific as we need to get. So what is happening to the velocity? Well, the velocity became positive. It jumped up. So it became positive. So now our velocity is positive. What happened to our acceleration? Well, this is pretty important. The slope is still flat. We're moving at a constant speed. We're not speeding up or slowing down, and so our velocity doesn't change. It just keeps going at that 1 meter per second. So our acceleration is still 0 because we didn't speed up or slow down. Now let's look at another situation. This time we're going to be moving to the left. Let's see what that looks like. Okay, our sensor picked up a bit more now, which is good. So if you'll notice with this one, we've got all this weird noise happening right here. What we really care about is this section right here. Let's go graph that out. So if we were to zoom in on that one piece that we care about, where the sensor was picking up the constant motion of the cart, what we would see is that instead of when it was moving to the right, it jumped up. Well, now moving to the left, it jumps down. So we end up with a line like this, like that. So let's go talk about that movement. So in this instance, the cart is moving to the left, and what happens to the velocity in this case? Well, when it moves to the left, now it's negative. We have a negative velocity, and we can see that because it jumped down below 0 on our graph. So what happens to the velocity? It became negative. And so in this instance, our velocity is negative. Whoops. And our acceleration is still 0. Because again, we're not speeding up or slowing down, we just have this nice flat line. So still 0. Now let's look at an instance where acceleration will finally change. It should get interesting. Alright, so we've got a situation where we have a car moving down a ramp, and for reasons I can't get into just yet, what we're going to see is that it starts speeding up as you release it. Let's take a look. Oh, look at that. So if I slow this down, you can see that it starts slow, but by the end of it, it's going a lot faster. Now look at what that did to our graph. It starts with a 0 velocity and then starts moving upwards. Let's graph just this part that we really care about over here. So in this instance, when we were at the start, at the top of the ramp, we were at 0, but then as we went down the ramp, the velocity kept increasing upwards like that. So let's go talk about what that means in our notes. So when we talk about the movement, it's going to be important to be specific now, because we don't just have movement from left to right. Now we're going down a ramp. So we're moving right and down a ramp. I'm going to put in parentheses, speeding up. And what happened to the velocity? We saw that it steadily increased as it moved down. As it moved down the ramp. Our velocity now is positive, and it's actually getting greater in magnitude. So it's positive now, and our slope is also positive because it's moving upwards, which means that our acceleration is positive. Our acceleration, there we go, is positive because we've got this nice slant. All right, let's look at a different but similar scenario. Okay, in this one, we're going to be moving a car up a ramp and then back down. And what I really want you to focus on is what it looks like when it moves down the ramp. All right, let's take a look. So we go up and then down. Let me pause it so you can see the actual graph. There we go. Okay, so this is kind of interesting. Notice how we have this very steep upward velocity, and then it levels out, and then it slowly comes back down to 0. Let's talk about what that means as we graph it out. So we can see that our velocity shoots upwards very quickly, and then kind of levels out, and then instantly starts moving downwards towards 0 as it heads away from the sensor and down the ramp, to the left and down the ramp. So what we really care about, what I really want to focus on, is this section of the graph right here. So when I put this in my notes, I'm going to specify that is the line that I'm really interested in. So which way is the cart moving? Well, on the part on this graph that I have specified, it's moving down the ramp and to the left. So down the ramp to the left. And in parentheses, I'm going to say still speeding up. Or I'll just say speeding up. Oops. Speeding up. Now, to be very specific about this, what is happening to the velocity? Well, it may seem like it is still increasing, but remember, we're going to the left, so we have a negative direction. So what I'm going to say about the velocity is that it's steadily getting, or it's steadily moving towards 0. Steadily moving towards 0. Our velocity is still positive, but now it's heading towards 0. So let's see. Positive velocity. Okay. In this instance, what it's important to point out is that the acceleration, the slope of the line, is now negative because we have a downward slope. We're heading in the negative direction. So negative acceleration. There you go. All right, let's look at another one in which this goes down the ramp once again. Okay, so in this instance, we started at the top of the ramp. So instead of pushing up and already moving, we started at 0, at rest, you might say, and moved downward. Let's graph that out really quick. Okay, so we start out at 0, and then we steadily head farther and farther down as we move down the ramp. Let's go talk about what that means. Okay, so again, let's be specific. Down the ramp to the left, starting at the top. That's important because it means that we weren't moving before we started. So what happens to the velocity in this instance? It steadily becomes more negative. You can see that on the graph. We started at 0 and we head down below 0 as we move. That's what we saw happen as this moved. So we're just going to describe that. Steadily becomes more negative. Okay, so in this instance, velocity is negative because we start at 0 and we only decrease. And our slope is also negative because we're heading downward. So we have a negative acceleration as well. Okay, and finally, let's look at what happens when we move up a ramp and then back down, but it's to the left. Let's see what happens. Okay. Oh, interesting. Okay, so let's go graph that out. So it looks like we started out heading towards the negative very steeply, and then slowly as we went down the ramp, we became more, or we got closer to 0. And again, just like the ramp last time where we started at the bottom and went up, I want to specify that what we really care about is this section right here. So in my notes, I would make some kind of highlight of like, that's what I care about. This is what's happening. So how would I describe that movement? So it went up the ramp and then back down. So what I'm going to say is that, so how would I describe that movement? Well, it's moving up the ramp, then back down to the left. Why is this important to specify? Well, because it already had a negative velocity once it started changing. So what happened to velocity? It started negative and it slowly crept up to 0. So comes to velocity, slowly moved up to 0 from a negative velocity. So in this instance, even though the velocity is steadily going up, it starts in a negative direction. So we can call it negative. Velocity is negative in this instance, and acceleration, because we're moving up towards 0, is positive. So we're speeding up, it's just that we're doing it starting basically from the left. Alright folks, that's all I have for you today. This set of notes is going to become sort of your cheat sheet for the next few days. It's going to be what you can look at to